Following on from the previous video, we were trying to evaluate this. We were trying to evaluate this from 0 to 1, and we had to take the limit of this whole thing here. Taking the limit of this, taking the limit of this is easy. Taking the limit of this is easy, but this here we need to understand what's going on here. So we would only consider this bit here. Then later on we will come back to look at the whole thing. But for the time being, we would just look at this bit here. So looking at that bit only, we would rewrite it as this. One thing multiplying another thing. And then as a tends to 0, this thing's going to be 0. This thing's going to be infinity. So here you've got an indeterminate product. So whenever you have a product, you should rewrite it as a quotient. So rewrite this thing as this, and then this gets multiplied to the top. So that will then take you to this stage here. Now we need to reevaluate this again. So as a tends to 0, if you look at this here, natural log here, your natural log of x looks like this. As a tends to 0 from the right hand side, it is heading towards negative infinity. So this bit here is negative infinity, and then you've got another negative here. So that means it's heading towards positive infinity. And then if you look at this here, if you look at this here, as a tends to 0, well, this thing here, if you look at this, you can rewrite it as this: 1 over a to the power of a half. Well, a to the power of half is 1 over root x here, 1 over root a. And then as a tends to 0, if you look at this only, square root looks like this. As a tends to 0, it is going to head towards 0, and then this thing here is heading towards 0. So 1 over something very, very close to 0, it will make this very, very, very big. It will make it very, very big. So here you've got infinity over infinity. Whenever you have infinity over infinity, you can apply L'Hopital's rule. So differentiate this. So when you differentiate log of a, it's going to be 1 over a, and then you times 2, negative 2. That will give you negative 2 over a. And then differentiate this. That will then give you this. So now it's just a matter of tidying this thing up. So let's just look at this bit only. So looking at this bit only, imagine this as being negative 1 over 2 times here you've got a negative 3 over 2. So rewrite it as 1 over positive 3 over 2, because here you've got negative. So remember, we are only looking at this bit only. So looking at this bit only. So here you've got one fraction multiplying another fraction. So top times top, bottom times bottom. That will then give you this. So here you've got a fraction. Here you've got a fraction, and then you divide it by this thing here. But then when you divide it by this thing here, you times the reciprocal of this thing here. So basically turn this upside down, and then multiply the 2. So basically, if you think about it, this thing here will become this. So now it's just a matter of tidying this up. Well, if you tidy up, it will give you this, and then tidy this up again. So this thing here will be this thing, which will be 3 over 2, take away 1. So that will be, this here is 1. So that will be 1 over 2. So if you tidy this thing up, this thing here will be 1 over, well, it will be a to the power of 1 over 2. And then as a tends to 0, this will be, well, this is like the square root of a. So as you tend towards 0, this thing here will be 0 times 4. The limit will be 0. So remember, hang on, we were here before. We needed to evaluate this whole thing here. This is easy to evaluate because it goes to 0. Because as a tends to 0, this thing here will tend to 0, because the square root of x looks like this. As a tends to 0, this thing will be 0, and then we've just worked out that this thing here will be 0, because we just worked it out up here. hang on. So it was blah blah blah, and then it turns out that the limit will be 0. So so as it turns out, this thing here, as it turns out, this thing here will be 0. This thing here will be 0. So as a tends to 0, this thing will be 0. This thing will be 0, leaving you with negative 4. So the area, so this area here is negative 4. This area here from 0 to 1 is negative 4. Is negative 4. Okay.